Hi, Elle. I just wanted to send you a video because I want to make sure that we're on the same page with these. Here's your paper that you sent me, and it looks like you're doing everything all right. If we look at number four, with a triangle that's got sides of 4 and 6, you've got 4 squared and 6 squared equal to c squared. That's great. 4 squared is 16, 6 squared is 36, and if you add those together, you get 52. So you've got 52 is equal to c squared, and in order to get c by itself, you take the square root of 52, and you get 7.2, which is really good. But I don't know how like numbers 3 and 5 in particular are working because if we go back and look at a triangle that has sides of 8 and 15, you're squaring 8 and getting 64. That's good. You squared 15 and got 225. I think that's fine. But 64 plus 225 is not 669, so I'm not sure where that's coming from. So I just wanted to make sure that you're getting the right answers on each of the problems, because it looks like you have the method down, but I'm not sure where some of these numbers are coming from. So let me write down here, and we've got a triangle for number 3 there. I'm just copying the one you had on your paper. You have 8 and 15 for your sides there. So I've got a triangle with 8 and 15 for sides. So if we come over here, we'll do the same work you were doing. You had 8 squared plus 15 squared is equal to c squared. That's good. And then you squared 8 and got 64. And if we square 15, just double check, 15 squared is 225. That's what you got as well, is equal to c squared. But now if we add 64 and 225, notice that you get 289, and that would be your c squared, right? So we're going to take the square root of 289 to figure out what c is, since if we were to square c, we'd get 289. So we want to take the square root of 289 to see what we get. And if I did the square root of 289, I'll show you what it looks like on my calculator. Square root of 289. We're going to get 17. So we could say c is equal to 17, since if we were to square 17, we'd get 289. The other thing that I noticed is just some notation stuff. I see like when you're taking the square root of 289, you're putting this here. I don't know, maybe it's got a little thing. You're saying 289. And I realize that like my calculator might do that. And there might be some stuff on the internet that looks like that. But when we write, we want to put everything underneath that little bar that goes with that. So, if I was taking the square root of 100, then there's a little bar over the whole thing. This square root extends over the entire number. We don't want to just stop it and say square root of 100. I keep breaking my lead. These aren't really kind of saying the same thing. We want to be careful with that because sometimes we put numbers after or before square roots. So you might see like later on in math, you might see like 2 square roots of 2x. Well, I'm not taking the square root of x there. So we want to be careful where that extends to and what it's over top of. And so what we want to do is extend it over the entire number that we're trying to take the square root of. So that's a notation thing, but I wanted to I'm not sure what we're doing when we got like 669 there. Looks like you got 669. The same thing's kind of going on with 5. You have a triangle that's got 5 on each of its legs, and that's fine. So 5 squared plus 5 squared is c squared. That part looks good. 25 plus 25 is equal to, I think that's supposed to be a c squared. And then all of a sudden you have the square root of 50 squared equals c squared, but you came up with 25. And I just want to make sure that we understand that the square root of 50 is not 25. The square root of 50 is not going to be 25. If you use calculator, you'll find the square root of 50 is 7.07 and not 25. So I'm not sure what's going on some of these problems. I just wanted to make sure that we are on the same page on this. We also have, for number 6 here, you got 4 squared plus 7 squared. That looks like a good setup. You got 16, which is your 4 squared. You got 49, which is your 4 squared. And then you wrote, it looks like you wrote 215, and I'm not sure why. We're also kind of changing the notation. Like up here, you were keeping your c squared on the right side of the equal sign, and that's good. But down here, somehow our c squared kind of disappears over here for a while and then kind of shows up. We need to make sure we're staying consistent. If we did 16 plus 49, on my calculator it says that's 65. So I think on your paper, what you want to be doing there, if you had like 16 plus 49 is equal to c squared, you'd have 65 as your c squared, and then you can take the square root of that and get like 8.06 for an answer. Right? So if we've got c squared on the right hand side of our equal sign, we kind of want to bring that all the way along. When we take the square root of both sides, or when we take the square root here, we can get rid of the square on the c and say c is 8.06. But till then, we probably want to keep our c squared on that other side there. So there's just some inconsistencies I see in here. I think you're doing a really good job of setting these up. Just make sure that you're following through, and like make sure you're taking the square root, not dividing by 2, or make sure you're not multiplying over here when you should be adding. Just keep your signs together. Make sure you're being consistent on all your problems and getting the consistent right answer. Okay, I think you're setting things up really well, and I like the way you're presenting your work. That's great. Just make sure you're careful and keep the right numbers in there. Okay. All right. Good luck. Oh, there was one other thing I was going to show you. If you didn't catch it from the video from today, I think I left the video for today. We still have like right triangles. Wanted to share this real quick with you so you're good to go with the worksheet, and hopefully are. If we called this side A and this side B and this side C, we know the Pythagorean theorem says that to get c squared, we can take, let's stay alphabetical, shall we? Mr. Foken, he doesn't know his alphabet very well. Okay. A squared plus b squared. So this is all true, but suppose that we have a triangle. We don't know what one of the sides are. So what if we're given the hypotenuse? I'm just going to use the standard numbers here. Suppose we had a triangle with a hypotenuse of 5 and a leg that's 3. Well, we know that c squared is going to be equal to a squared plus b squared, but right here it's giving me my c, and maybe I know what my b is, but I don't know what a is. A is my unknown. How do we work with these? Well, we can kind of rearrange this equation and say, well, you know what, if I took c squared and I subtracted a b squared, I'd get my a squared. That should kind of make sense. Because this is the bigger number. When you add these two together, you get that. So if you took this bigger number and subtracted one of the smaller numbers, you get the other one. So let's go ahead and do that with the numbers. We're going to have 5 squared minus 3 squared will give us our a squared. and that's going to be 25 minus 9 would give us a squared. 25 minus 9 is 16 for our a squared, and then if we take the square root of 16, we'll find out that our a is 4. So that's how we'd go through and find one of the legs if we knew what the hypotenuse and the other leg was. All right, that maybe would help you get some of the problems that are on the worksheet for today, if you've gotten stuck on those maybe. Anyways, let me know how things go. Good luck to you. Stick with it. You're doing good. And hopefully we'll talk to you soon. All right, bye-bye.